Now let's talk about 2D vectors known as non-collinear vectors. Non-collinear vectors is basically any two vectors that each one of them is going in a certain direction different than the other one. So it is basically saying, in other words, non-linear vectors, because we have two vectors in this case, so they are co-linear vectors. So when you have all the vectors in one axis, let's say x-axis, each one of them is on the head of the other one, those are called collinear vectors. While if each vector is going in a certain direction with a certain magnitude and angle, then we call them collinear vectors. So vectors in more than two planes, in more simple words. So if we have our directions as east, west, north, and south, you have vector 1 going east, that's the tail, and that's the tip of vector 1. And you have vector 2 going northeast, and you need to find the resultant of those two vectors as we learned in the vectors addition. In this case, the resultant is going from the tail of the first vector to the tip of the second vector while taking an angle. How to solve non-collinear vectors, how to add and subtract them, that's what we will learn in this lecture. So the steps for adding non-collinear vectors graphically, so either we can solve this kind of problem graphically, or we can solve it algebraically or using math. So for graphical, you can create the appropriate scale. You have a certain problem, it's telling you vector 1 is going 2 meters to the right and vector 2 is going 3 meters to the left. In this case, you need to create a scale because you can't draw 3 meters on the paper. So you need to say each meter in the problem equals 1 centimeter on the paper and so on. So you create the appropriate scale. Then you choose a set of reference coordinates. So you can say this is the origin, this is the y-axis, this is the x-axis. That's where I will start to draw my vectors. Then you draw vector 1 to scale, as we did here. Then you measure its direction from the tail. If it is going east, then you can draw a straight line with a magnitude, let's say, of 5 centimeters and so on. If it's going west, it's going an angle, going north, northeast. All of that will be done based on the problem. Then you draw vector 2 to scale, and his tail will be on the tip of the first vector, as you see here. Then you draw the resultant vector, which connects the first tail with the last tip, and you measure the magnitude, or the length in this case, of the resultant. Then you measure the direction, in this case the angle of the resultant from its tail. Then you use your scale to convert the magnitude of the resultant to its original units, and you state the resultant vector. Then you need to remember to include both the magnitude of the resultant and the direction, or the angle in this case. Let's learn how to do that with an example. So you have a camper that left her tent to go to the lake. So her tent is the origin point, as we will see in the drawing or in the graph. She walked 0.8 kilometers south, then 1.2 kilometers east, then 0.3 kilometers north. Find her resultant displacement. So what we're given, delta D1 0.8 kilometers south, delta D2 1.2 kilometers east, delta D3 is 0.3 kilometers north. What is required? Resultant displacement delta dr. Now that's the tent. So the question is saying delta D1, he went 0.8 kilometers south. Then on the head of that first vector, we draw the second one. It's going 1.2 kilometers east. Then it went in D3 0.3 kilometers north. What is resultant? So the first tail to the last tip, draw a vector there. That's your resultant vector, and there is an angle to it. Now you draw from here to here, then you measure. As long as you're drawing to scale, you are measuring how long, or what's the measurement between the first tail to the last tip. That would give you, the scale here is 0.2 kilometer, would equal this value. And you switch back the units back to the normal scale. So By doing that, you can find in your ruler that the delta D resultant equals 1.3 kilometers. As simple as that. To find the angle, we already draw that, but we don't know what's the angle. For that purpose, you can use a protractor and you'll find the angle between this vector and this vector is 67 degrees.